Welcome to another episode of math class. You can see on the board we've got lesson 90. We're going to add and subtract rational expressions. Today's episode is brought to you by alligators. Alligators, they make the world go round. Or something. We've done a lot of adding and subtracting of all kinds of different expressions. We've done polynomials, we've done fractions, we've done all kinds of things. And today is a kind of fraction, right? Because the word there is rational. But basically, rational expressions are fractions with variables. Variables, if you're in French class. Fractions with variables, and we got a few different things that we're going to try to do with them, depending on the format of them. If we find out that we've got some fractions which have same or like denominators, then we can combine them very easily, like regular fractions. Or if they've got different denominators, we're going to have to resolve the denominators. We're going to have to find the least common multiple or least common denominator, or I like to call it the first common multiple or denominator. There's also going to be some simplification we can do if we can. We might as well simplify a problem, make it a simpler problem before we go on. I'll give you an extra trick today to look at. But fractions are fractions are fractions, and so because the fractions follow fraction rules. Fraction rules follow rules of algebra and just normal arithmetic. For instance, if these things have the same exact denominator, then we're allowed to put all the numerators over one denominator and sum it up really quickly. I mean, we kind of like think of this as 3/16 and 5/16. You can just hear the answer happening, right? 8/16, which might be reducible, but it is just how many sixteenths do I have? And for me, 8/16, 1/2. That's one of the keys to dealing with things when we throw in letters, we throw in variables in there. Now, if they're different, we followed rules for that. And we'd find the least common multiple, or the first number that we would get to that they would have in common as multiples would be 12. And we did something like this to fix those. So this one turns into 3 and 8. But all of them are now 12ths. So we can put that over one denominator and have 3 and 8 is 11, 11/12. I mean, we've done this for a long time. Fractions are always a little sticky, but we will follow the same types of rules as we do there with just numbers when we throw in things with letters. This one right here, you have the same denominator, and so this one can be combined over 20. We have 2x squareds and 3x squareds, and that'll give us 5x squareds over 20, and then that's reducible down to x squared over 4. I kind of almost think of it, all this stuff that's the same in both of these, we can say like llama or something like that, for all the stuff that's exactly the same in both of them. And we've got 2 llamas and 3 llamas, and that gives us 5 llamas. So we have 2x squared 20ths and 3x squared 20ths, and that must make 5x squared 20ths. Okay? Think of it like, it's a bunch of junk there, but it's all the same. So if that's the case, that's exactly like this type of fraction where we know we have 3/16 and 5/16 makes 8/16. Where it gets tricky is when we have those letters in there with different denominators. Or if we've got something like this, even just 2 totally different letters in there, and we got to think what's the least common multiple. We'll talk about that. This one right here, we're going to follow the same type of deal as we've got right there. We're going to think 3 and 2. The first common multiple of 3s and 2s is 6. So I'd multiply this one by 2s and this one by 3s. Now everything's going to be a sixth. I'll have 2h cubes over 6, and then I'll have minus 3h squareds over 6, and then there's really nothing else for me to do with that because the h cubed and the h squareds are different. They're not the same. I have llamas and camels. Okay? So this is the style that we're going to follow. We're just following the same exact rules as we do with fractions. Let me do this one too, and then we'll work some other problems. Yeah, we'll work some other problems and maybe talk about alternate ways to solve some of these so that you have more tools in your toolbox to explore. Here, I'm trying to figure out what would be the least common multiple when my factors are x and 3 and y. Okay, so those are all of them. I've got to collect all of those. In the same way that 2 and 3, I need to find 6. I had to use multiples of these things. So there it is. It's 3x and y, or 3xy would be a common denominator. And I just need to think, what is each one missing in order to get to 3xy in the denominators? This one only has an x, so it's missing 3 and y. If I do that top and bottom, I multiply them by 1. And this one's missing x, so I got to multiply by x top and bottom. I can already see that my denominators are going to be the same, and that's why I would go ahead and just start writing down as much as the answer as I know. That's going to be the denominator. And the top will be 3 times y, and 7 times x, and then I'm done. If I do any fancy stuff, I'm going backwards, right? I'm going back toward this split up version. I don't want that. I want one denominator and a bunch of stuff on the top. So this is a simpler version of the original expression. I have maybe, even though I've got a sum on the top, I have just factors on the bottom, which is preferable. Okay, so let me take up the problem 3a minus 2 over a plus 2, and we're going to subtract, I think I got the a minus 6 over a plus 2. Okay, let me get rid of this stuff now. I think you've had long enough to copy that kind of thing down, and I want you to look at that for a minute. Do you notice what type of problem is this with the fractions, at least? You've got the exact same denominator. So that means we can combine the tops, except we have to be very careful with negative signs. We've talked about this over and over again, and we got minus some type of expression. That negative sign applies to everything in there, like it needs to be distributed. Well, I already know that the denominator is going to be a plus 2. It's the same. And so I can start combining the top, but here I would probably put this in parentheses and have that a minus 6 there. So simplifying the top, though the bottom is already done, I've got 3a minus 2 minus a, and then minus 6 plus 6, which I could rearrange into 3a minus 2 plus 6, which simplifies down to 2a. 3a minus 1a is 2a. And negative 2 plus 6 is the same thing as 6 minus 2, so that's 4 over a plus 2. And I could leave it like that, except I notice here that, that top is factorable. Here comes some simplification. There's a factor of 2 in each piece of it, and lo and behold, the factor on the top and the factor on the bottom now can be canceled out, and that one boils down to 2. You wouldn't think that 2 would be a simplified version of that, but it is. But it is. All right, I'm going to pause and clear the board and put up a couple more problems. We'll work our way through ones that have dissimilar denominators and what we're going to do about that. Okay, I got the next one ready to go, and I'm going to talk fast. So we're going to take up the fact that these are different first, and then we'll do some simplifying over here first. But here we got not the same denominator, so we'd have to figure out what would work. We've got 6 and h. 6 is 2 times 3, and then we got an h. And over here we got a 2, and we got 2 h's. And we want to find the biggest, or the first multiple of all these factors that they would then be able to share in common. So both of them have a 2. This one's got a 3, so we would need to include one of those. And this one's got 1 h, this one's got 2 h's. if we multiply this by h, we can get there. So 6h squared would be our common denominator. What do we got to do to each fraction in order to get them to be over 6h squared? This one needs an extra h. So we go h over h. And this one needs to be multiplied by 3 over 3. And that'll give us, on the top, 2h to the 5th plus 12h squared. Now these can all be reduced a little bit because the top, we can say there's a 2 and there's an h and there's 2 of those. So we can factor out that and be left with h cubed plus 6. And the bottom was 2 times 3, so I'll put it like this. And this is the new numerator, and this is the new denominator. 2h squared can come out of the top and the bottom. It could be simplified that way, or I think, let's sure hope that I did that one right, or else I just wasted a whole bunch of time. Yeah. What you might have thought to do here, and you look at it and you're like, man, it's a lot of messing up and then have to clean it up, clean it back up, is we could have simplified first, right? You got h to the 4th over h, and you got a 2 over 6. So that can reduce down to 1/3, and this can reduce by taking out an h. You could have h cubed over 3, like that was. And then here we can reduce this down to 2 over 1. And then the h squareds could have canceled out first. So that, of course, there is 2. And we're all stinking done. And we didn't have to do all that other junk over there. That's silly. We get to a simplified answer way quicker. Just the way that they wrote that one, that it's actually easier to simplify first, and then there's really nothing left to do. Except maybe if I want all this over one denominator, I might think of it like 2 over 1 and multiply this by 3 over 3, get h cubed plus 6 over 3, but that's the same thing as I had right there. Okay, alternate version for that one. Got 2 more to do, and we got to move through them fast. Left side first. This looks really complicated because, like, they're totally different denominators, right? Except maybe this actually has an x minus 4 in it because this is a quadratic and it's factorable. So my eye goes there first instead of multiplying this by this and getting some really nasty junk. I want to see if this is a factorable quadratic or not. And so I take my negative 20 and divvy it up into its factors that would add together to plus 1. And I'm like, oh yeah, I know some. How about plus 5 minus 4? That makes negative 20. That sums up. So, oh golly gee, look at that. There's an x minus 4 in there. So really, this one is x minus 4, x plus 5. This one's just missing an x plus 5. This is that version, alternate version. So all I got to do now to put everything over this x minus 4, x plus 5 is to multiply this first bit by x plus 5, and then I have minus 2. This expands then, there's my common denominator, to x squared plus 3x plus 5x is 8x, plus 15 minus 2, and 15 minus 2 is 13. So there would be my numerator. There's my denominator. I'm going to leave it like that. And that one's done. X squared plus 8x plus 13 over x plus 5 times x minus 4. Sorry to switch that. Okay. So there's that one. And I'm going to have to give you the 3-minute version in the next video because I have like 28 seconds left. But we'll knock it out. It'll be 3 minutes or less, I promise. Will you please watch that one too? Thank you so much. I appreciate you.